If you've gotten to this point, you know how programming courses work. Every time there is some new syntax or feature of the language, there is accordingly some kind of hideous tracing question that you have to do on the midterm for it. So it's practically one of Newton's laws by now, so obviously you should expect to have to trace through some code involving exceptions on an exam. This question here is a bit shorter than what you'd see on a midterm so that I could fit it on the screen. What you might see on an exam would be more print statements. You might see a print statement like here or something, so that way if you get halfway through and get stuck, there's still some marks to give. I've deleted those because if I trace through it correctly, you would agree that we could stop anywhere we wanted and print everything out. But it's very common to see exception tracing questions with a structure sort of like this, with a few different functions and a few different scopes. This does not contain an example of, for example, exceptions being thrown in loops, or exceptions being, or a try block inside of a loop, or a try block containing a loop. We saw in previous videos, though, how such things would work. So I want to go through at least one complete tracing question involving exceptions. So I'll make a place to put my output here. And then we'll just start tracing in main and hope for the best. So one thing I encourage is when you have to do a tracing question involving exceptions, I think it's pretty important to make sure you have scoping boxes for everything, and especially try blocks, because a try block is a scope. And many of the features of exceptions that we need the most rely on the fact that try blocks are their own scope. Okay, so we enter main. On line number 19, we create a variable x. It is going to be an int. Its initial value is fittingly 116. And then on line 20, we enter a try block. So I will make a note of that as a nested scope because it is. There it is. I'll make a note that this is a try block that started on line number 20. And immediately on line 21, we see some shenanigans. I don't know if this isn't really exception handling shenanigans, but we say auto x. So we already have a variable called x in main, but not in this scope. So we are allowed to make a new variable called x. In an earlier tracing example, I observed that you can actually figure out the type of x without finding its initial value. You could figure that out before you evaluate the right-hand side. And I'm going to do that, especially because I don't know what's going to happen when I evaluate the right-hand side, although I have some suspicions. So the type of x is what? Well, the type of x is going to be the type of this expression, f of -1. Okay, so f of -1 is a call to f, and whatever the return value of f is will become the type of this x. Well, f returns an int, so this is an int. All right. Now, I'm going to treat the remainder of it, the initialization, sort of like an assignment. I don't want to think too much about x just yet. I want to first evaluate this call to f. So I make a box on the diagram for f. I think I've budgeted my space rather unwisely here, but we'll make it work. Okay, so there's f in this strange landscape mode scoping box I've drawn for it. F takes as its argument a single value called y, and we can see that what I'm clearly passing in for the value of y is the integer -1. All right, and then I enter the scope of f, and we can see I create a variable called, so I'm now on line number 7. I create a variable called sum, and it is also an int. Looks like we have ints all the way through in this program, and the initial value of sum is 0. Okay, and then on line number 8, I enter a try block, and that is a nested scope. And I'm now really regretting making such a comfortable try block up here in main where I didn't really need it. Okay, so there's my try block on line number 8. Now, there isn't actually any variable declared inside the try block. I don't think it matters. I still make a scoping box for it, just so that I remember that I'm in a nested scope. Okay, so I hit line 9. Line 9 is a sort of assignment statement, so I cross off the left-hand side and begin working on the right-hand side. The right-hand side is a call to the function g. So I have to ask myself, what did I do in the world to get myself into a situation where there's no space for a box for g? I'm going to put g's box sort of here. Sorry about this. There we go. There's my box for g. G, fortunately, does not contain any nested scopes. So it's actually got more space than f the way I've drawn it. It takes a single argument z. We can see here I'm passing in the value of y. So in f, when I call the function on line 9, I'm in this scope. In this scope, there is nothing called y, but out here, there is. So the value that I pass in for y, for z, will be the value of y, which is -1. All right, so the initial value of z when I start the call to g will be -1, and now I'm ready to actually begin executing g. So I start at line number 2, and I ask the question, is z less than 0? And I would argue that it definitely is. It's -1, so it's less than 0, which means I throw an exception. Okay, so I throw domain error. And I have to somehow keep track. The diagram doesn't really give me any easy way of doing this, but I have to somehow remember that I've thrown a domain error. So I'm just going to put a box around that to make a note of that. And then I have to figure out how far back the code has to unwind. Remember that I'm going to keep ending scopes until somebody catches this. And if nobody catches it, if I get all the way out of main without anybody catching it, the program gets terminated. Okay, so it gets thrown. In the current scope, like in G, there is nothing that could catch domain error. There are no try blocks. So that means that G is going to end. Okay, so I end G. On the diagram, I destroy it. It is gone because the scope is now over. The only thing that survives is the thing that it threw, which is this domain error. Everything else is now gone. And so I erase it from my diagram. That takes me to line 9. On line 9, that's where I call G, am I in a try block? And the answer is yes. Can this try block catch domain error? And the answer is also yes. So I know where I'm going to stop. I'm going to stop on line 9. I have some way of catching it. Now, when I catch something, so if I'm in the middle of a try block and I catch an exception, the try block does end. So that means what I'm going to do is end the scope for the try block. You can see I'll erase it here on F. And then I jump immediately into the corresponding catch block. Now, we can see the catch block is going to end immediately anyway, but for the sake of appearances at least, I should observe, because I'm entering the catch block on line 10, it has curly brackets, it is a scope. That means the catch block should be drawn as a scoping box on my diagram. Okay, so I never did the rest of line 9. Line 9, we bailed out and ended up in this catch block. On line 11, which is where I end up, which is where I land after that exception from G finally gets caught. I take the domain error I was given. Notice that I don't use the error message. I just look at the domain error and then return 10. So the return value of F is going to be 10. Okay, so I go back to where I called F and I write in 10 to make a note of its return value. And then, because it's a return statement, F is going to end. Okay, so I destroy everything here. As usual, I make sure that it is gone because I don't want to get confused later if I call F a second time, and maybe I will. So I get rid of this, I erase it completely. I'm not doing a very efficient job of erasing today. There we go. And then I return to where I was when I called F, so I'll just clean that up too. So when I called F, I was on line 21. I was in the middle of initializing this variable x. I now know its initial value. It is 10. So then I'm done with line number 21, and I get down to line 22. Line 22 prints some output. It prints out x is, and then it prints out the value of x. Well, I'm in this scope here. So if I go looking for the name x, I find this thing. And so I print out x is 10. Then I get to line 23, which is an assignment statement, and it's a call to F. So unsurprisingly, I'm not done with F just yet. I'm going to try putting the box for F here this time. I don't know if that's a good idea or not, but we'll see if that's any more roomy. Okay, so there's there's F, and I'll cross off the left-hand side of the assignment so that I can focus. The argument I'm passing into F is the number 1, so F takes takes a single value y, and that's going to be set to 1. And then F initializes a value called sum to 0. So I'm now on line 7. Okay, so then on line 8, I open up a try block, and I can sort of cram that in. There it is. There we go. And then on line 9, I call the function g. Okay, so on line 9 again, I'm going to cross off the left-hand side so I can focus. I'm going to make a box for g. Now we're going to try putting g in the landscape mode box here. I'm going to pass in the value of y. We saw earlier there is no y in the current scope, which is the try block, but there is a y out here, so I pass in 1 as the value for y. That means that g accepts as its argument the integer 1. There we are. And now I'm ready to begin executing G. So I was on line number 9, and now I'm going to go up to line 2 and begin executing G. I ask the question, is Z less than 0? And the answer, this is Z. The answer is no. And so the function skips over that throw and returns 6. So the return value of G is going to be 6. So I go back to where I called G. I'll just cross off G and write in 6 as its return value, and then G is ready to end. And so I destroy its scope and everything inside of it. So there it goes. It's all gone. And now I'm back on line 9. And so I finish off line 9. Line 9 was sum plus equals and then the function call, so 6. So I go find the variable sum and I add 6 to it. There is no variable sum in the current scope, but there is a variable sum outside of it. Okay, so sum is now equal to 6 and the try block ends. Okay, so I end the try block, I get to line 10. I never go into any of the catch blocks this time around, so we'll just erase that. And then I get to line 13. Line 13 says, is sum greater than 5? And the answer is yes. And so I throw an exception. So I throw runtime error. So I make a note to myself that I threw runtime error. And because I'm throwing an exception, I have to begin ending scopes. I have to keep ending scopes until somebody catches the exception. So here, the current scope is F. F is not a try block. Like the scope that I'm in here, this is not a try block, and so this scope ends. And so the function F is now over. And I go back down into main where I called F originally. The only thing that escapes F being destroyed is the exception that I threw, the runtime error. So I go back down to main. I was on line 23 of main, and an exception has been thrown all the way back to line 23. So I ask, is the current scope a try block? And the answer is yes. The second question, can this try block catch the exception that I threw, which was runtime error? And the answer is also yes. There is a catch block for runtime error. Now, that means that I go back to line 23 and an exception gets caught, which means the try block that I'm in must immediately end. And so I erase the scoping box for the try block and everything inside of it. It is gone. And notice how important it was to do that, because there was a variable called x in there that has now been destroyed. And so when I land, I'm on line 28. I'm inside a catch block. So I draw the scoping box for the catch block just to make sure I keep my thoughts in order. And then I go to line 28. And on line 28, I print out runtime error. And the catch block then ends. Now, although the example doesn't contain this, it's valid to declare variables in a catch block if I want to. I could put a try block in a catch block. I could call functions in a catch block. I can do anything I want in a catch block. That's why it's really important that I draw a scope on the diagram for my catch block, because I can do anything I can do in any other scope inside a catch block. But I don't do that in this example. So I'm done with line 28. I get to line 29. The catch block ends. So I erase it. I destroy it and everything inside of it. That's not going to be so hard. There we go. And then I get down to line 30 where I print out the final value of x is, and I go looking for the value of x. Well, I mean, as usual, that freebie print statement at the end of the output, I just have to print out the only variable left at all is this x in main, which is 116. So that wasn't just a question involving tracing of exceptions, but you'll notice it was sort of a nice backdoor way of reviewing some scope tracing, because this variable x I created inside the try block isn't the same variable x that I had to use when I got down to line 30. But in any case, there is the output. And we saw in that how we trace exceptions using this diagramming format, where we have to keep ending our scopes until somebody is actually able to catch and handle the exception.